All right. Hello, everyone. Welcome to our Thursday panel. Super excited to have everyone joining, panelists and attendees. Thank you so much for being here. My name is Heather Grant. I am one of the community admins at the maintenance community by Upkeep. Thank you, everyone, again, for being here with us today. If you are not already a member of the maintenance community on Slack, we would love to have you join us. I will send the link on how to sign up in the chat in just a moment. Feel free to pop into the chat as well, say hello, let us know where you're joining from. The recording from our session here today will be available in the community Slack tomorrow, along with a couple of final resources from the conversation today. All of the panelists here with us today are also available to answer questions live in the Slack group. So feel free to share the recording of this webinar or the invitation to Slack with friends or colleagues if there's anyone else you know who would benefit from hearing some of these expertise. Last piece of housekeeping, and then we'll go ahead and get started. You'll notice your cameras and microphones are not turned on today. So if you want to ask any questions of the group as we kind of go through our activity, you'll use that chat feature on the right-hand side of the screen. As they come up, feel free to ask away, and we'll do our best to incorporate them into the conversation. But any questions we don't get to, we can always answer offline in the community as well. That is our little housekeeping spiel. I'll go ahead and get started with a quick round of intros to our wonderful speakers here who will be leading our conversation today. And then I will do a quick recap of our previous panel, as this is part 2 in a series on troubleshooting lubrication failures. Awesome. So somewhere on your screen on my top right, but I'm not sure where everyone else is sitting, we have Sonia.
I'll start this again.
Yeah, we're doing it. We're all in. Ravi brought it up, so.
Yes, you did.
Yeah.
We have Sonia Matura joining. Sonia is from Trinidad and Tobago and the founder and managing director of Strategic Reliability Solutions. She has her BSc in Electrical and Computer Engineering, MSc in Engineering Asset Management, and ICML MLE certification. She has written her first book called Lubrication, Degradation Mechanisms, a Complete Guide. Welcome to the panel, Sonia.
Hi, I'm so excited to be here. No, we did not work on our passing skills. This is live and unscripted, so we will work with that.
I love it. Up next, we have Andy Gailey joining. Andy is the director of Uptime Consultant Limited, based in the UK, with worldwide clients in many industries, including food, automotive, utilities, robotics, and more. As a mechanical production engineer with a background in manufacturing and automation, he's interested in mitigating the pain of future failures by evangelizing, I practiced saying that word, but couldn't quite get it, proactive and predictive maintenance strategies. He has authored and published many articles on diverse topics and is in the process of writing his first book, aiming to share his journey in engineering. Hello, Andy, and welcome today.
Hello. Welcome to everybody that's come along. It should be fun. It should be fun.
Awesome. Next up, I have Bob Latino. Bob is the CEO of a 50-year-old reliability consulting, training, and software firm called Reliability Center, Inc. Bob is one of the founders and developers of the ProAct RCA methodology and software, as well as their new Easy RCA investigation management system. Bob is an RCA practitioner, educator, consultant, and author of several books and articles on the topic. Welcome, Bob. Happy to have you here.
Thanks for having me back after the last time. It's always a coin toss. You never know.
And then last but certainly not least, we have Blair Fraser. Blair is a technology evangelist, see that word comes up again, with a natural curiosity to think differently and challenge current thinking. He is the director of Global IIoT Systems for UE Systems, the Global IIoT Solutions for UE Systems, and the co-founder and advisors of many companies in the technology space. He also co-hosts a wonderful podcast. If you haven't listened, go check out Maintenance Disruptive.
Thank you for that.
You're
Thank
welcome.
you. Greetings, everybody. And to get it out of the way, it is snowing here in Toronto. So those from Nigeria, UAE, it's snowing here.
Yeah.
But Dylan from Edmonton, you probably still have feet of snow, so I don't feel so bad.
Wonderful. I'm super excited to have these 4 awesome panelists back again. I do want to just take a moment to kind of recap a couple of things we talked about in our last panel before we dive into our activity for the majority of our time together today. So last time we spent the session discussing some typical warning signs that equipment is failing due to a lubrication degradation issue. In particular, those are acoustic temperature and friction changes as indicators that something is starting to malfunction. Beyond those specific failure modes, we discussed the importance of matching failures to the surrounding environment, right? So differences in physical space, as well as culture and people working on equipment, all are components and can contribute to a lubrication failure. We also touched briefly on how technology fits into the equation of lubrication and many other types of failures, really, through sensors and data analysis. Then finally, we discussed the importance of failure analysis to the deepest level by investigating failures holistically and thoroughly in order to prevent similar failures from happening in the future. Today, this is kind of the area where we're going to spend most of our time, like I mentioned, diving into an activity that will take some of these concepts that we talked about last time and put it all together in a way to help us think through some of this process of troubleshooting lubrication failures. We'll go through this exercise, which Bob can explain much better than I can, on how to kind of put some of this knowledge together in a practical way and kind of preserve this information that these experts and many of the attendees here as well all possess. So Bob, with that, I will turn it over to you to kind of get us started.
Thank you, Heather. And hold on a second. I'm getting back into role again. This is failure scene investigator.
Oh, yeah.
Different day, different hat. That's all it means for me.
Yeah.
I can't have a bad hair day. Okay, I want to go through and I want to start with a background of an event. And then this is, I want you to look at this realistically as if we were forming a team. This event just occurred. The panel and the audience is going to be my team. And this is going to be very realistic because there's going to be a whole bunch of things that we don't have answers for or proof. So, but that's to be expected, and this is real time. On June 15th of 2019 at 4:30, production at this particular factory had to be reduced when the quenching section could not meet the quality level of cooling needed. The cooling water temperature had increased due to the failure of the number 2 cooling tower cell fan motor. The production department was required to slow the line down to meet the quality specification of the quenching section. It took the maintenance team 5 hours to replace the motor and return the number 2 cooling tower cell back into service. With the cooling capacity of the tower now fully restored, production was able to return to normal. Now, this is a typical failure statement in this because all it's doing is representing the facts that occurred. It's not saying what we think happened. It's not saying what we think caused it. It's just what happened. Okay. And the next slide I'm going through now is talking about the cost associated with it. And this becomes important for the beginning of the analysis because we all know that I don't think that we do RCAs on incidents. I think we do RCAs on consequences. And if the consequences aren't significant enough, then we're not likely to go into in-depth doing an RCA. So in this case, the impact of the reduced production level was about $200,000 in lost revenue opportunity. The repairs cost another $44,000 for maintenance labor, crane rental, and riggers. The motor was sent to a repair shop for rebuilding and testing where the bearings were retained for future examination, and that cost about $6,000. So we're looking at a total loss here, about $250,000. Okay, while we're going to go through this case, we're going to learn about the lubrication degradation failure in this case. I also want to get across the part of the collaborative nature of RCA and how we take information from SMEs and we have a facilitative process, and then we have to capture it. If you look at the right side over here, my team in this case is going to be this esteemed panel and you all as the attendees. But also you see far off to the right here is that one thing we won't have in this particular scenario is that we won't have the evidence that we need. And this is true even if we were in the plant. I do this for a living, and you go through and you come up with hypotheses, but people can't cross anything off because they don't have any evidence. They have to go out and get it. Now, the really important thing here is that me as the facilitator, I'm just a guy that asks questions. These people off to the right have all the answers. So my job is
We
to
will
get
try.
my job is to get all of this all this intellect out of these really smart people, and then put it into a logical breakdown into what we're going to form as a logic tree. So that's really what we want to do. And the role of a facilitator is to get that information out of other people's heads and get it into a recording mechanism. So given that, I am going to escape out of that and go into here. Okay. Now, notice in here that the event in this case is going to be the process slowdown lasting 5 hours, costing $250,000. In terms of a logic tree, I want you to understand that the only block that your leadership is really going to be interested in is that one, because they don't care about why a bearing failed. They don't want to hear about lubrication related things. They don't want to hear about overload. Is that they just know that in that black block right there, that failure cost that much money and cost us production. As we go down here, the failure mode is going to be a fact. In this case, what we know in this case is that the cooling tower #2 fan motor had failed. Now, this is like if on these top two blocks here, if you had put like a crime scene tape around those two, that's what we know about events and modes, is that they happened. Our job is to explain why they happened. So when I come off of this cooling tower fan #2 and I say, how could the motor have failed? Now I become hypothetical. And notice that these lines on the perimeters are solid. And when we start this process, they're going to become a dotted line. And that accounts for evidence, is that we're going to have to go in when we have a hypothesis. That means that it could be true, it could not be true. But then that guy carrying the proof earlier, that now has to become the evidence to say whether it's true or not. When it becomes true, we put a solid line. So in this particular case, we know that the cooling tower fan motor failed, and the hypotheses previously were the armature and the winding failed, the bearing failed, and the housing or the casing was a potential failure. These were possibilities. And the evidence collected at the time demonstrates that we did have a bearing failure. Now, I think I'm going to ask Andy, because when we were going through this case, we had a question about this particular bearing. And Andy, do you want to say what we were discussing?
Yeah, it's always good to know the type of bearing you're looking at. So is it a deep groove ball bearing? Is it a taper roller bearing? Is it a Cooper split bearing? Those are the types of bits of evidence, especially if you're in a remote area gathering the data. You probably won't be able to go back there very easily if you've got permit to work to do so. It's always good to take a smartphone with you or a camera, and make sure you take critical things down, like what was the temperature that day? Was it snowing in Ontario like with Blair, or was it 23 degrees like it is here in England? So it's always good to have those bits of evidence that will add to the story later.
Okay, I'm going to, for the sake of example and being more generic, I'm just going to use a roller element bearing. And I'm going to, at this point, say, well, how do we know that was true? And I'm going to add what we call a verification log off here to the left, and it's going to say that, how do I know that? It's going to be, I'm going to have a metallurgical review of the failed component. All right, then I'm gonna, as Andy was saying, I'm gonna go ahead and I'm gonna put in a graphic here. And this is obviously just for mock's sake, to come in here and say, this is the bearing we took out and we're having it staged so that we can go ahead and split it for examination by metallurgical people that are really smart in that area. Okay.
So Bob, just so I'm clear here, so and just like the many of the participants in this, although I'm on this panel, this is not my forte. And I'm going to naturally just put some technology on it, and you're going to solve your problem, and you guys have to steer me away from that. But so we made a hypothesis that it's a rolling element bearing, and then we made a verification task that we need a metallurgist to verify it's a rolling element bearing.
Yes.
Is that because we see a picture there? Like I can tell, I'm not a metallurgist, I can tell it's a rolling element bearing. Is there a reason you have that level of detail in that specific verification? Or is there like a common, like, do you get to see in RCAs where if you don't have an exact verification by like, I'm not by any means a bearing expert, but I can tell a rolling element from a sleeve bearing that it is a rolling element bearing?
No, and the purpose that I used that picture, that's a good point, and a way to keep me between the guardrails too, Blair, is that the fractured surfaces, as we go down underneath here, what we showed is that the bearing was taken out and now it's being staged for a metallurgical review. So I don't have a conclusion from the metallurgist yet. I'm just showing how we prepared it to be presented to the metallurgist. It's sent to a staging area, and all we're doing is proving that the markings were on there, and we're going to have it split, and then they're going to go. It's going to go to a lab or a person who knows. They can tell a lot from just looking at it.
Right. So we're not at this point. We're not verifying that it is a rolling element bearing. We're getting that next step for that metallurgist to begin his or her analysis of it.
Well, no. In here, for the sake of this example, I am saying that we're going to run with, in this case, that it's a rolling element bearing.
Okay.
And then from here on, we're going to say that proved to be true. And my next question is going to be, well, how can a roller element bearing fail, which would result in that motor failure? So I would be seeking the possibilities of how that could occur from my panel and from anybody that wants to chime in. And I want to, this is, I know this seems like semantics, but when you're going through this questioning, you have to be like you're the bearing in this case. And that sounds stupid too, but in terms of increments of time, it's almost like, feel that you're the bearing and what just happened to me. Because the natural tendency is to jump to, it was installation, it was the manufacturer, it was misalignment.
That's where my head's already at, Bob. Exactly.
And I'm trying to get across the fact that when you look at the physics of failure, you're going to get there. You just have the faith that you're going to run into a person and then you're going to run into systems. But for right now, I want to know, if I was the bearing, what are the ways that I can fail? Mm-hmm. Well, when that metallurgist gets this particular bearing, they're going to look for certain patterns on that failed component. And what would you say is the ways in which a bearing can fail?
You will always have some sort of corrosion, some sort of fatigue, wear. Of course, you must have some kind of wear going on there. What else would you have? Overload. Overload is a huge one. Okay.
When you look at any component, and I'm saying this because we teach classes on why parts fail, and this is a little known fact, but when you look at any components, especially just steel, is that the only ways in which whatever you were thinking in your head about lubrication related, misalignment, and all these other things, they eventually are going to cause one or more of these failure patterns to surface. Okay, and just keep the faith, Blair, because as we go backwards.
Oh, I have faith in you, Bob. I'm thinking because I probably can relate to. I'm not very proficient at these type of details, and
right.
And I think this structure, because even if I was to answer this question, like right. how would that fail? I would go, I think, a few levels where we're eventually going to get to, and not linked to the failure mechanism. I would go to, it's undergreased, it's overgreased, improper installation, and I think Ahmed went there as well. Like I would end up at a very low level and make assumptions in the middle part of that tree, right?
Right. And then that's why a good point is that when we're going, and this is real time, is that oftentimes, what do you think takes the longest amount of time in an RCA to do in terms of physical tasks? What do you think takes the longest time to do if you do it right?
Verifications. What is just me? I just think verifications.
Yeah, that's a good point to actually
time.
to put. Yeah, I don't know what the step would be called, but to verify someone's assumptions.
Yeah. Collecting evidence is what takes the most time in any investigation. And the reason I brought that up is to your statement, Blair, is that's why a lot of people say, I don't have time to go get evidence. So they let hearsay fly as fact. And that's why you get assumptions that will be used to confirm something. And, you'd never use that in court. So, I go to court and they say, well, how do you know that? Well, Blair told me so.
That's right. That's right.
Going back to the tree bob.
Yes.
For the other viewers and for myself, if we were to use this tool, would that be self-populated? So if we were to doing this in another week's time and we had another roller element bearing failure, when we hit that box, would we get a self-populated 4 modes of failure pop up? Could you have that?
Yes, but
because they cover all of the basic kind of base failure modes of rolling elements. So I know you've just typed that in, but if we used the tool, would it self-populate and just pop up?
Yeah, and again, I don't want to make this your point is valid, and I don't want to make it about the tool, but the bigger issue that you're talking about is that I don't see RCA as a task. I see it as a system, and that the overall goal and benefit of a structured, disciplined RCA effort is going to be the amassing of that knowledge management base. So the answer to that is yes. And I'm for the sake of just example, and I want to use this lightly because it's a key differentiator for me as a purist in my field, is that I am an advocate that it was Eli Goldratt who wrote the book, The Goal. And one thing I got out of that book was the fact that an expert is not somebody who gives you the answer, it's somebody who asks you the right questions. And in RCA, if I just go ahead and give people drop downs to pick from, then they didn't learn. Yeah. If I ask you the question right, then you will have to use the derivation in your own mind, and you will have to derive that. Now, given all of that, is that I'm an advocate that you should exhaust the knowledge of the team and then hit on the external knowledge and the external databases. To see if I went into here and say fatigue, and you see that little brain thing light up over here, these are all the different ways in which fatigue could crop up.
Yeah.
This is all the ways that overload can come up. So the answer to your question, which is very astute, is yes. That's the overall arching purpose of aggregating knowledge and logic from various people. But for the sake of example, I'm going to say that this was not true. This was not true. We're going to go with overload as the mechanism in this case, which proved to be true. So then my question becomes, and when you're going through the physics of failure, this is, my job is a cinch, because you just keep asking the same questions until you get to a person. And then we're asking how can in the physics of failure. Okay, when we get to a human and why they did something, we're going to ask why. But right now, I'm going to say, how could I have an overload of a bearing resulting in the fan motor failing? What would be your hypotheses that you would come up with?
You can have excessive internal loading Like, let's start with the bearing just not being able to handle it.
All right. You could have somebody who doesn't know how to type. Okay.
Okay, that could work too.
What about improper bearing selection?
All right, hold on just a second. Let me, I'm having an operator malfunction.
Oh no.
All right. Improper bearing selection. Is that what you said, Blair?
That's what I said, yeah.
Okay. All right. What else?
Well, if it's an overload thing, what if we overloaded the bearing itself? Like, we had an excessive load on the bearing.
Couple
Could
of
be
answers
due-
coming in.
you've got a fan as a unit, so it could be that you've got damage to the fan. There's
Good call, Andy. Yeah.
let's put that out of alignment. Cracked blade or missing blade. All of a sudden you've got imbalance going on, which can overload.
Yeah, Andy brings up a good point, and I'm going to give you a little tips and tricks from RCA. Is that as you come through here, and I say fan damage related, that opens it up because I already know what the next question is. How can I have fan damage? So then it would give me the ability to break it down into specifics.
Yeah.
Okay. You see how I use that? Heather, you had some external input?
Yeah, there's a couple of answers coming through in the chat. I'm not sure if they fold into any that have already been mentioned, but Ahmed says a surge of a load due to misalignment. And then we have another, Yogesh said misalignment as well. And we have one more from Dylan, says improper placement of a bearing. For example, a thrust bearing in the wrong orientation.
All right. Improper thrust of a bearing. Okay, I want to, again, tips and tricks. Several of the things that our attendees gave me to put in, I want you to think about when you ask the question to say, if I put that on here, will it cause one or more of these things we've identified to occur? Because things like misalignment are going to be subordinate down here. They're going to cause these things to occur. Fair enough?
Mm-hmm.
Yeah.
Okay. So because we only have a 1 hour show today, we're going to say, and these are all valid, and I want you to think about as I'm going through here, a lot of people ask me, well, why do I have to put all the things on here that aren't true? Well, because if you didn't check them, you wouldn't know they weren't true. So why do I express them on here? One, for the collection into that aggregate database, but two is also what happens when you put all these things that aren't true and you go to your final meeting with the leadership. Do you think that that's going to prevent a lot of questions from occurring to say, well, why didn't you check this? And why didn't you check this? And so by putting things on the tree, you avoid questions because of people saying you didn't check something. So that's another tips and tricks. Okay, so now excessive internal loading, that's the one we're running with because we're in an example. How can I have excessive internal loading?
Let's go to lubrication degradation mechanism. I'm aiming for that one. So let's try that one.
We know we hit Sonia's sweet spot now.
Oh yeah, definitely.
Okay. Any other way that I can have excessive internal loading?
If the bearing doesn't fit right, like, something is wrong with it, I think that kind of falls with the misalignment part.
Or improper installation.
Yeah, improper installation.
Or fit, yeah.
Yeah,
Fit's
let's
good.
leave it at fits, yeah.
Okay. All right, anything from our guests, Heather?
Yeah, Dylan says excessive preload.
Oh, okay.
We
I have
have
I have a feeling I know this, Dylan.
I think so too.
Yeah.
Thanks, Dylan.
Can we make a new panelist here and get Dylan over here?
we have excessive thermal growth and then thermal growth again. So a couple of people mentioning thermal growth.
You see, Yogesh says an improper fit, so a clearance, like C1 instead of C3. Kind of somebody got the fit wrong, so you could have a big shaft in a small hole, and all of a sudden you've got that internal load being transferred through the bearing.
Okay. Again, going through this in terms of demonstration of process, this is exactly the way it works. People are giving you legitimate answers to these questions. And then, it's really interesting when I go through this, because even though we go through great lengths to collect evidence ahead of time, you're likely in a real-time situation, if you get 60% of what you need, you're having a good day. But as you can tell, running through this logic and going through it this way, it tells you what you don't have. So, on some of these, you're going to say, well, did you check the thermal growth? Well, no. Well, now you know what you got to go do. You got to go out there and see if that was a factor or not. Okay. Example. We would be shot by Sonia if we did not follow a lubrication degradation.
And I have 6 different ones that I want to put under here.
Well, they're fresh in your memory, and my memory's blank, so go ahead, run.
Let's do thermal degradation, because it could be that. Why not?
All right.
It could also be oxidation. We can have microdieseling. We can also have electrostatic spark discharge. Maybe we just put ESD, so it's not as much to type.
Yeah, that's too many $7.
Yeah.
That's too many $7 words for me to type. Okay.
Oh, yeah. We can have additive depletion as well. And Dylan got it right. Contamination as our last one. High five, Dylan. I think you're reading a good book.
He's reading a book.
That's right.
Okay, so there are ways in which you can go through and test for each of these, correct?
Yep. Each of them has a different result. So with thermal degradation, you would get carbonaceous deposits. With oxidation, you have varnish and sludge. Microdieseling, what you're going to see is pitting on the inside of your equipment. With ESD, you're going to see burn patches on your filters. Additive depletion, you'd have to verify that with the lab. And with contamination, depending on how much contamination it is, you can actually either physically see it or you can verify that in lab. So,
okay. So realistically, doing this in real time, I would be able to go to my little paper clip here, and if I put something in here, that's this. So actually, if I put anything in here, it's going to, I'll bring up just one picture. It's not related to this, but it's going to hit Blair's point. Because after reading the fractured surfaces, you're going to be able to put the pictures on there that would say how a metallurgist would read it. And this being, you see the traditional beach marks of a fatigue type failure. So, whatever, whether it's a metallurgical report, whether it's an interview, whether it's an OEM policy, you can attach anything you want in here, but it has to be able to serve as evidence to prove or disprove the hypothesis. And ideally, every block on here should have a paperclip. Because, again, people looking at this, visually digesting it, should be able to read a story based on the colors, the line, whether it's perforated or not, and whether there's paper clips. Okay, if I'm coming down thermal degradation, my question is going to be how could, and my possibilities are what?
Either you have too much lubricant or too little lubricant, because we're working the tray backwards and making sure that whatever we put here, we can read it back. So if we're saying too much lubricant because of thermal degradation, because of a lubricant degradation mechanism, because of an overload, then that has to make some certain sense. So either we have too much or we have too little. And one of the things that we need to remember is having these broad and all-inclusive categories. Because while we have so many things that we could put here, if we put it into smaller chunks that sort of encapsulates everything, it's going to be easier to read the tree. And you're not going to have as much branches, going all the way out. And
Right.
I know it happens to me a lot. I want to put everything on the tree at one time, but Bob has taught me to put it into a nice little block and make sure that it works properly.
That's all right. My friends call me blockhead. Just wait for it.
Oh my gosh.
We're getting
Okay.
we're getting a couple of suggestions. I think for the line that we just selected true on, but there's a couple of suggestions in the chat, including surge of temperature or maybe the wrong lubricant.
That's a good one.
Mm-hmm.
I like how you are thinking.
What was the other one, Heather? I'm sorry.
Temperature surge.
Okay.
Yeah.
And see, that's the beauty of this, is that you're oftentimes the SMEs see something so often that you go with what you see most often, and then the ideas come out from others and say, well, I hadn't thought of that, and that's all. That's exactly why you do things like this. Is that you're everything is a hypothesis on here until it's proven to be true or not true. So, and to Andy's point earlier, this stuff now that they're bringing up that others did not find is going to go into that knowledge base for future analysts and say, these are possibilities that you should check. Okay, and the only reason I'm expediting a little bit is I want to get into some human stuff here in a few. But I know we have limited time. So how much, if I said, how could we have too little lubricant, what would be my possibilities?
Either you have a leak, because it could be something's wrong there. And I think we have probably had it before. If we had lubricants being broken down because it was the wrong lubricants. So that kind of falls under too little. And we can also have improper lubricant replenishment. So they're not, something's wrong in terms of how often or how much of what they're doing.
All right.
That's what I was thinking. If you could have a planned maintenance routine that is supposed to be carried out every 12 weeks, but it gets missed for some reason. Or somebody decides to do it twice, which I've come across before. So somebody got allocated two tasks to do because they didn't do the previous one, so they did it twice because that's what they're told to do. So then we get to the people bit.
Okay. On this one, we're going to take the case and we're going to say that we had improper lubricant replenishment. And my question would be, how could we have had improper lubrication replenishment?
Yeah, I think just as Andy said, either we had the recommended intervals were less than adequate, or maybe the the PM that was scheduled for the fan was not, what if the PM that we had originally scheduled for the fan changed because of some sort of condition?
Somebody's
Okay.
come up with somebody's come up with a good one. Neil has come up with incorrect specification in the OEM manual.
Yes,
That's a
yes,
really
I love
good
that one.
and it's a very common one as well.
Mm-hmm.
Okay. And I want to show you as we jump back from this and look macro into micro what we've been going through, because you can see that we get into the weeds on this. But what we've gone through the physics of this now. We're getting into the human decision making, and now we're starting to explore systems stuff as to why people do what they do. So in this particular case. We're going to say, I think it was the PM scheduled. Yeah. Is that the one, Sonia?
Yeah. Yep, that's
okay.
the one.
All right, so let's go ahead here.
Let's try that one.
And say, people chose not to do a performed PM. I mean, a scheduled PM in this case. This is a cue. Again, tips and tricks is that we're at a point here where there's a choice. Someone is making a conscious decision to do or not do something. So now what that switches is that we take out of that how can questioning, and now we're going to move into why. Because when we get between somebody's ears, I'm not asking how could they do it, because there's an infinite number of possibilities. I want to know why on that day that person felt it was the right thing to do. Because they were well-intended people, why did they think it was the right thing to do? So what would you give me as a reason for why someone would not choose to do a scheduled PM?
Could be maybe access to equipment. Operations didn't give it up, or I guess you do want to lubricate while it's running, but I'm saying like no access to the equipment.
Okay.
We can have, supervisors, they saying that, let's not do this. Or, telling your staff, okay, well, maybe not today, guys. We have other things to do. Because we know it happens.
Good one, Neil.
What was another one from Neil?
Neil's was lack of available technicians to perform the task,
Right.
or
Definitely.
yeah, just a resource issue. It's putting out fires all day, and you want me to go and lubricate? That's not going to happen.
Oh yeah, nope, not today.
I'm just creating another fire for tomorrow. Oh, good one, Dylan. Yeah, parts or grease wasn't available.
Yeah, it happens.
Heather, if I could ask you, because we have about 39 people on, if you go ahead and throw that viewer link in, that shouldn't be a problem.
Happy to.
Okay. I'm sorry, what was Dylan's, Blair?
Dylan was, we'll call it parts not available.
Yeah. Okay.
In this case, it'd be grease, but or even maybe a grease gun. I can't lubricate without a grease gun.
Yeah. And please don't use anything that you find in the yard. It happens too often. It's the first thing that they find, they just use it.
Okay, Heather is going to put in the chat a link, which it should allow you to be able to see this particular tree being built in real time. And the reason that I'm doing that is so that I'm trying to emphasize the collaborative nature of RCA is that you don't have to be in the same place. And the viewer link also allows that, you don't want your managers changing your stuff, but they have the right to look at it. So this is a good way of protecting your work product here, but also satisfying people's need to see status. Okay. Okay, so now I'm going to go ahead and I'm going to say, because I can, all of these are true.
Oh yeah.
Okay. So we're going to say that's true, And that's true. Okay. So the reason that I want to be able to go through this, oops, I want that to be true too, is that these are systems types of things. And I could go a little bit deeper if we had more time, but I want to make a point about the root cause systems, about labeling things. Think of this like a Christmas tree. I'm just putting some fancy balls on the tree.
Oh yeah.
And I could also now come in here because we got to do something about this stuff.
Mm-hmm.
So now that we can go in here and we can say that we're going to put in a corrective action. Now, systems related stuff influences people's decisions. So in here, to me, this is going to be what I call a human root, and which is just the act of making a decision. And then as a result of that, the first physical consequence that we can see of this is going to be that we had improper lubricant replenishment. And that's going to be what I would call a physical root. So this is the way that the system works in terms of RCA, is that the red blocks, which is our systems, influence the orange blocks, who's our well-intended decision makers. As a result of their decisions, they trigger a series of cause and effect relationships to occur that we can see. And now you can see that the eye just follows the colors, and you can find out in this case what happened. But the more important thing to me is look at all of this data you got from these experts about things that didn't happen, but could possibly happen. And now they go into a knowledge base where fancy technologies like Blair's an expert in terms of using AI to be able to sort out exactly what you need in these cases, to be able to pre-populate a lot of analyses ahead of time, like Andy was talking about earlier. Now, I think Heather is going to also put a link, however we figured out to give this tree in there. It's not going to look the same because that's part of doing stuff live. It doesn't always go the way you tracked it. So
Yeah, that's all right.
okay, so I want to go in here and I'm going to say, I'm going to bring up the one that Sonia and I are working on a different project, but it looks something like this. But this is what this is very natural, normal, what a normal tree would look like. All right, for the sake of example, okay, I'm gonna try something really new. And I have no idea if it'll work. But I'm gonna ask for those because COVID has been makes us learn new things. So when we were going to restaurants during COVID that were open, they would say, we don't have paper menus. Try this QR code. So what I'd like to be able to do is say there's a link there, and Heather, if you could please put that link in the chat.
On it.
If we were to do this again, I'm kind of curious as to there's 5 more mechanisms on here. I think I took oxidation out. I'm sorry.
Oh man.
Replace thermal degradation with oxidation. And say, if we were to do another one, what would be the topic that you would prefer to see?
Yeah, this is very interesting for us actually, because where we want to be able to help you all with different mechanisms that you all may see in your plants, in your equipment. And usually when we talk about lubrication degradation mechanisms, we go into these 6 of them. And which of the 6 of them do you really have a lot of issues with? And you want to see a similar type exercise on it, just let us know, because we are working on something and we want to make sure that you're
Hint, hint,
definitely
hint.
getting stuff. Hint, 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 hint.
And when she says we, it ain't me.
Yeah.
Not me.
Yeah.
I'm gonna say in my defense here, my panel, I do have oxidation here. I just got the other one wrong.
Oh.
Okay, so it's a predominant here would be the topic of contamination. That if we were to go through a
boy.
contamination example, hey, wait, but additive depletion is
additive
quickly
depletion
catching
is
up.
coming up. Oh yeah, that is a very interesting one. So I'm
All
glad
right.
you're going towards that. So yeah, you.
The key takeaway from that exercise was that it worked. Okay.
Yes. Thank you, Bob.
I had no idea whether that would work, but it was a little rough around the edges with screen shares, but
You did fantastic, Bob. Changing screens and everything.
Well
It
done.
was fantastic. So, Bob, I'm curious from your expertise, and Sonia would see this just from, Bob, your expertise on facilitating these RCAs, and Sonia with your in-depth knowledge around lubrication failure mechanisms is my gut, and it just happens, like I grew up in industry, like working for a living, then now I'm on the other side of the fence, but my natural reaction was if I had a failed bearing, I would pop it out, and like a lot of the times if it's like I would pop it out and the balls would just fall out in my lap, right? And I'd be like, and I look at it, I'm like, there's no grease in it, right? And I like, well, RCA, no grease. What are we gonna do? We're gonna grease. Now, talk to the player 20 years ago, I'd say, well, here's our PM. We were peering, once a month. We're going to do it every 2 weeks. And I've solved all the world's problems, which we know is not the issue. But how do you decide? And I think that's why you put the cost up there. How do you decide when to do an RCA, when it warrants it to go through that level of detail? And when it's just like, hey, dude, you missed your PM. Like, why? Right? Like, how do you balance that?
I'm going to real quick show you, and that's an extremely legitimate question. And this is part of a setup in doing an analysis, for at least for us, is that what's the likelihood that it would recur if I did nothing? And what would be what was the impact of the initial failure? So if I come in here and I say that it's very likely to happen again, then this is going to recommend that I do a full-blown RCA. If I come down here and I say it's in here, I'm going to do a fishbone analysis. If it's low impact, if I come over here, we're going to do a 5 Ys.
Brilliant. I don't know why
See, that's a very good question there.
Yeah, it just answers. I should really be on the attendee part of this panel, but this is fantastic. Yeah, that makes just a lot of sense to me.
So you could go in and you can do 5Y, or you can go in and you can do. Everybody likes their fish to go upstream, so I gotta turn it on its side so that it looks like a fish. So
Yeah.
okay.
We got a really interesting question from the audience here from Lance. If we have a few minutes at the end here to answer it, I would love to throw it out to the panelists here. Lance asks, do you have advice for holding the team accountable to completing these proper due diligence when facilitating a seasoned team of SMEs who have reviewed the same failure in the past and maybe tend to brush the potential causes aside without data, as they see it as maybe a waste of time and resources? Long question, but any advice for kind of holding the team accountable, doing maybe an exercise similar to this?
Well, I mean, from my standpoint, and I know oftentimes it looks like it's the team. If I have to do, I advise people that if you have to do an RCA on the same thing twice, is that the second one is going to cite the deficiencies in the first one as a root cause. Because oftentimes it was either a poor quality RCA or we didn't implement what we said we were going to implement in terms of recommendations, or they were the wrong recommendations. We implemented them and they didn't work. So I would advise in situations like that to find out, if you've done RCAs before, why haven't they worked? And I just did an RCA on a webinar a week or two ago on, I called it Doing RCA doing an RCA on why RCA programs fail. And it's usually, and I go through a tree just like this, but you know, an RCA is not just a tree. I mean, there's methodologies involved. There's people that have to do it. There's management support. There's expectations that have to be set, because if leadership doesn't set an expectation for me on my RCA effort, I can meet that one. So if there's no negative consequence for not doing something, then it's not going to get done. I mean, just think about when you the normalization of deviance concept, and saying that when people take a shortcut because of time pressure and nothing bad happens, then all they've done is they've eroded the standard that was there before. And now a new lower standard has been set because I didn't have to do that step. It took less time. I got more productivity, and nothing bad happened. Yeah. And that goes that way until something does happen, and then all of a sudden you're disciplined and you're the bad person. But everybody's been doing it that way for years. Mm-hmm. So you know that I call it the hero to the zero concept in about 30 seconds.
Cool.
It is a real thing that happens. I can empathise with Lance. Some people get involved in RCAs, and then they may become the person at the end of it that has the task to go and put it to bed forever. Mm-hmm. And if the personnel are stretched, they may not get around to doing it. And it is, like you said earlier on, just before, it beggars an RCA on the RCA process if that happens, because that means that the support of the management team isn't strong enough to support the people on the front line. Mm-hmm. And I can see where Lance is coming from.
Yes.
It's a people thing. It's a management thing. The thing is that if I've seen RCAs used as a tool as well on sites to tick boxes to say they've done the RCA.
Yep.
And they don't understand that the RCA is the tool to get to a root cause and to put it right and never to have it happen again. Mm-hmm. A lot of processes in plants get to this. We triggered a half an hour downtime. Therefore, we do an RCA and we finish it. We put it in the file, and that's a bad RCA if it doesn't end in an action. I often said I like the idea of root cause analysis, but I would change the A to action.
Right. And to Andy's point, and this is true of any type of analysis, I'm sure Blair would agree, but an analysis is only as good as the analyst. It doesn't matter the tools that you have. You have to have the will and desire to do it right. So if I want to create a really fancy, like we were talking about the logic before, Andy, I can do a bunch of things. I can use those drop downs and make a really fancy and impressive looking tree. It might not be right, but it'll impress people by what it looks like. Yeah. And if I go ahead and I put some different color blocks on there, that's even better color. But it doesn't have anything to do with the substance of the content. Mm-hmm. So that's why I tell when I train management in this is to say that if you want to increase the quality of your RCAs, then start rejecting them. Start looking when people present them to you and you see deficiencies and they didn't collect evidence to see something, or they didn't broaden their understanding and the questioning, or they didn't involve the right people. Then start telling people that and say, go back to bring this back to me when you fill those holes. I guarantee you the second time they come back, that it will not have that deficiency.
Mm-hmm. That's great advice. Well, we are up at the hour mark here. Lance said some great culture and leadership opportunities to seeing our RCA actions through. Thanks so much. So thank you all for sharing there. I have one more question if you all have 2 minutes, but we can also leave it there. I know that we were a few minutes over last time. My question, or maybe food for thought then, would be kind of how does this activity, how does creating RCA on this, like what are the first actions that you take then in order to kind of rectify the failure and make sure that it kind of gets incorporated into your system so it's not repeated? That's my kind of food for thought for how to take this to the next step.
Have a really good CMMS system. You can utilize that. The output of the RCA goes into a work order to be actioned, I think. And then obviously you tag the RCA to the work order so you can be tracking that in time. And it's something I used to do in predictive. If we found something with a predictive technology, we'd raise a planned work order that then when that bearing was changed in downtime, so we avoided a failure, we'd go back and we'd grab the amount of time it took them to do that in a planned event, and then we'd add that to a database. Then that was our proof of return on investment. So, and as Bob alluded to right at the start, the guy at the top of the organization, he wants to know what's in the black box at the top. He's not particularly interested in the methodology. And at the end of a quarter or a year, he'll be asking you, how much of that did you save? So when I was working full-time in predictive, I was working with predictive tools, but my aim was to save the company revenue. People must be aware of that. These are just tools to save the company unplanned downtime and revenues, and repeating the same failures over and over. So a good CMS like Upkeep would be the answer.
I'll see you there.
To Andy's point too, as a caution, is that most CMMS systems are catered and designed for repair functions. A lot of what you're going to find in RCAs are those system deficiencies, like obsolete procedures or poor incentive systems and things of that nature. So it's not the conventional thing you see in a CMMS, but there's ways of manipulating a CMMS to accommodate things like that. So it's kind of out of the comfort zone of a traditional CMMS, but you have to find a way to get those admin type things, which are much more sensitive than the repair tasks, because that may involve somebody's. There's a lot of I'll just say there's a lot of politics involved with systems and who created them and who followed them and all that kind of stuff.
Well, very cool. Thank you for spending a couple more minutes. That was just kind of my one wrap-up question I wanted to toss in. There's a couple more thoughts in the chat. I'll leave those open for the next few minutes, but I do want to, again, be respectful of everyone's time, knowing that we've gone a couple minutes over. Thank you so much again, Bob, Blair, Andy, and Sonia for joining us today. It was a really great conversation. Thank you so much to the audience for their active participation. It was really fun kind of going through that exercise all together. That link, I believe, to the one we created today will stay live, as well as that photo of the one that Bob and Sonia had previously completed. So feel free to take those and use them as a resource. I think that's all I have for you today. Here's the emails of all of our wonderful panelists. Feel free to reach out with any other follow-up questions. I'll see you all in the community. Thank you again.
Thanks, everybody. Great seeing you, my friends.